Hello, everyone. Okay, so today you should have done your delta math before you watch this video. Again, if you have not done the delta math yet, please pause the video here, go do your delta math. Okay, so here is our warm up for today. It says for number one, it says which one of these are scaled copies of the original? So just like I said yesterday, a scaled copy is when all of the sides are multiplied by the same amount, whether it's a large number or a smaller number. Um, so the original triangle is a 3, 4, 5 triangle. Um, so if I look at A here, to go from 3 to 4, that would be like multiplying wise would be 1.3 something. Where 4 to 5 would be 1.25 and 1 to 6 would be 1.2. These ones are from T to A is just adding one, but that is not what makes it a scaled copy. You can also tell that the right angle is not um still perfectly right. So in T, this is a perfect right angle. In A, this is not. It's more of an acute. B is a scaled copy because a scaled copy can still be the exact same thing. All sides are multiplied by 1. 3 times 1 is 3, 4 times 1 is 4, 5 times 1 is 5. So B is one of the scaled copies. Okay, so again with C here, 3 to 4 is times 1.3 or times 4 over 3. Where 4 to 5 is times 1.25 or times 5 over 4. So without even looking at the long side, I already know this is not a scaled copy because of the 4 and the 5. Okay, for D, 3 to 4.5 is times 1.5. 4 times 1.5 is 6. And 5 times 1.5 is 7.5. So all of these sides here were multiplied by 1.5. Okay, E, I'm going from 3, 4, 5 to 6, 8, 10. 3 to 6 is times 2, 4 to 8 is times 2, and 5 to 10 is times 2. So this is a scaled copy. And F is another one that you could kind of just look at and see that it's not because this is not a right angle right here, right now. But 3 to 6 is times 2 again, but 4 times 2 is not 7. If you said 4 times 2 is 8, that gives you this one, but then 5 times 2 is not 7. So this would not work. So it's just B, D, and E. Number 2 says to identify this angle. This little square in the corner here means it is a 90-degree angle, which is called a right angle. Number 2 is a right angle. Okay, number 3, multiplying whole numbers with fractions. Like I said yesterday, the whole number is basically saying over 1. So you'd always just multiply across 6 times 2 and then 1 times 3. Or don't even worry about putting the 6 over 1. Just multiply the 6 or multiply your whole number by the top number. So 6 times 2 is 12. And then just put the 3 at the bottom. A lot of eighth graders want to do the 6 times 3 as well, but you do not multiply the 6 by 3 because it would technically be over 1. And then you do want to simplify. So 12 divided by 3, or 12 over 3 is equal to 4. Okay, number 4, describe the transformation in a complete sentence. Now, this transformation is a sequence. It is two transformations again. So if you said a rotation, that is great. It is a 90-degree rotation going counterclockwise, but 90-degree rotation would put C prime right here. So you also have to go down 2. You would also have to translate by 2. So the complete sentence with number 4 would be triangle ABC was rotated 90 degrees counterclockwise around the origin and then translated down 2 units. That is the complete sentence for 4. So if you did not get 4 correct, or if you made any small mistakes, fix those mistakes, write this sentence. And before we move into the notes today, I do want to show you guys that I am grading what you guys complete. I am looking at what you guys complete while I'm down in Florida. So let me clear my drawings. So looking at the Nearpod that you guys were supposed to do Monday, yesterday, because you're watching this in class, Tuesday. It is currently Monday while I'm recording this. I'm looking at what you guys completed on the Nearpod yesterday. So you were supposed to watch the video of me giving you the definition of congruent and looking at your video percentage, the percent of the video that you completed. I only had 2 kids in 3-4 complete 100% of the video. If I go back to my 5-6 class, 5-6 did do the best in completion wise. I had 5 people in this class complete the video 100%. But again, notice I have some people that did not. I have some people that didn't even started in each of my classes. And then 7-8, my largest class, still had the same amount of students hop on as the other ones. So there were students yesterday that didn't even watch the video of me. So if you are watching this video of me now, and you know that there are other students in the class that didn't watch their video yesterday, you better tell them I'm calling them out. So if you see somebody's name and their name is not on this list on the side, they didn't do the video at all yesterday. 7-8, not a single one of you guys fully completed the video yesterday. So you guys really need to make sure you're using your time wisely because I am going to be putting this grade in the grade book. But enough about that right now. Let's go ahead and do our notes practice for today. So you guys should have this worksheet in front of you. Yesterday we identified or really defined congruent figures. Today we're going to identify whether the figures are congruent, and we are going to explain using transformations why they are congruent. Okay? So congruent figures have the same size and the same shape. This is very important right here for the definition of congruent figures. If 2 figures are congruent, you can map one figure onto the other using one or more of the following congruence transformations: translation, reflection, and rotation. So here's an example one for you. This was triangle 1, and this was triangle 2. Figure 1 and figure 2 are congruent. Figure 1 can be mapped onto figure 2 by a rotation 180 degrees. So 180 degrees would put this triangle here. Okay? 180 degrees would put that triangle there. And translation 3 units down. So it moved 1, 2, 3 down to fit on top of this one. You guys should have access to patty paper in my classroom. I did not bring patty paper down to Florida with me. So I'm going to kind of draw out what's happening here because I know what the shape is. But I would love if you guys kind of traced over with patty paper and use the patty paper to help you like I showed you guys last week. So determine if the figures on each coordinate plane are congruent or not. Write your answer below and explain your reasoning. If the figures are congruent, describe congruence transformations that map figure 1 onto figure 2. So figure 1 here is congruent. They are the same shape, I know, because this side here, to go from this point to this point, I went up 2 over 1. From this point to this point, up 2 over 1. Then if I go from this side and this side, it's up 2 over 3, up 2 over 3. And then down here is just a nice straight 1, 2, 3, 4 units, 1, 2, 3, 4 units. So Size-wise, shape-wise, it is. Now, to prove the actual transformation, I can see go from this point, well, really, I'm looking 1 to 2. This point to this point, I can reflect over the y-axis. This point is at 5. This point's at -5. I can reflect it over the y-axis. This point is at 6. This point is at -6. I could just reflect it over the y-axis. So figure 1 is congruent to figure 2 because it can be mapped onto the other using a reflection over the y-axis. Okay, go ahead and write that down. Okay, this one here is pretty easy. You should easily be able to see that square 1 and square 2 are not congruent because 1 is so much larger. If they are congruent, they are the exact same size. So I'm going to say figure 1 is not congruent to figure 2 because I cannot map it onto the other using just translations, rotations, or reflections. Later on in a couple of weeks, I am going to tell you how you can map this onto this one, but it is not using these 3 transformations. These 3 transformations keep the shape the exact same size and shape. There are other transformations that change the shape size, and that's what's happening here. So the other transformation I'm going to be teaching you later because it's in its own separate unit since it does not stay congruent. This unit is mainly focused on congruence. We want them to be the same shape and the same size. Okay, let's flip to the back. Okay, so this says determine if the figures on each coordinate plane are congruent or not congruent. Write your answer below and explain your reasoning. If the figures are congruent, describe congruence transformations that map figure 1 onto figure 2. So figure 1 to figure 2, again, I just want to double check my sides. And what you guys should really be doing to check this is using patty paper. If you use patty paper, trace figure 1 on the patty paper and then try to match it up onto figure 2. If you can make it match up onto figure 2, then it is congruent. Again, I don't have patty paper. I did forget to bring it down to Florida with me. But I can see that my side lengths are the same. I know that my angles are the same. All of my side lengths are exactly the same. My angles are exactly the same. I know this because I know how to look at it and double check it. For some of you guys, you can be like, yeah, Miss Rhoda, I already know how to do that with this one. But the triangles are more difficult to use. So please, please, please use patty paper to help you with this. So number 1 to number 2. Well, it looks like it's been kind of turned, but it's also been moved up. So I am going to rotate this 180 degrees first, and then I am going to figure out how I have to translate it. So if I rotate this 180 degrees, it is going to look like this. This is what a 180 degree rotation would look like. around the origin. Oh, my little baby's down here. It's okay. The kids can enjoy a little baby in the background. Okay, so now that I have rotated it around the origin, I need to move up 1, 2, 3 units. So this is a rotation 180 degrees around the origin and a translation 3 units up. So let's go ahead and write that sentence. Figure 1 is congruent to figure 2 because it can be mapped by a rotation 180 degrees around the origin and then translated 3 units up. Okay, go ahead and get that written down. Okay, the last one I'm going to do with you is these two. Again, please use patty paper. Trace figure 1 and then try to map it onto figure 2 here. This does look like it can be a reflection and a translation. Um, but I just want to show you if I was to reflect it. So if you trace this on your patty paper, you flip your patty paper over and slide it over, you'll see that it's not perfectly matched up. Because if I was to reflect it, it would map out right here. This is the reflection. Then if I was to translate it over 4 units, it would actually look like this. So if you were using your patty paper, you will see that it does not match up perfectly. So we want to say figure 1 is not congruent to figure 2 because you cannot map it onto the other using just translations, rotations, or reflections. Period. Okay? So I do, let me make sure you guys can take a second to write this down. I do want you guys to do these last two on your own so I can check them when I get back. So take a second, pause the video here. Try doing these two on your own. Again, please use patty paper. Draw number 1 on your patty paper. Then flip, turn, move your patty paper to try to line it up with number 2. If it matches up, then I want you to try and figure out the transformations that get it there. Same with this one, trace shape 1, flip it, turn it, move it to try to match it up with 2. If it works, tell me what transformations would take it from here to there. Okay? So try to do those last two. I want to see how you do with them when I come back tomorrow. Okay, and then the last thing I want to do with you guys today is the Desmos. So today's Desmos is called Are They Congruent? So you should see this Desmos assigned to you. On this first one here, you are going to do this one on your own. I want you to just make a prediction. So if you get it wrong, that's fine. Or you're actually going to see whether you're right or wrong on the next few slides. But make a prediction by selecting each one that is congruent. So if you think A is congruent, you're going to select it. If you don't think it's congruent, just don't select it. So go through each of these. whichever ones you think are congruent. Same size, same shape, angle measurements are the same, side measurements are the same, area, perimeter. If you can use translations, rotations, or reflections to map one onto the other, then I want you to click on that shape. Okay, so slide 2 is going to look at pair A. So it says press play and watch a sequence of transformations. Precisely describe the sequence of transformations. Explain how you know the figures are not congruent. So first, we're just going to watch it. We can see it slid over, down, and then it rotated a little bit around the point. I know this says precisely, but that rotation is different type of rotation than normal. This rotation is not a full 90 degrees and it's not around the origin. So we can just say that it rotated a little bit around point C. But we know that it went from, hold on, let's pause at the beginning, from here all the way over here. So that's a translation 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the left. It translated 9 units left and 1 unit down, then rotated less than 90 degrees around point C. Again, the translation was pretty simple. I counted how far it slid over and how far it slid down, but the rotation again, it did not fully match. It did not go a full 90 degrees and it stayed on point C. I know that it was around point C because it didn't move from point C. But notice it still did not line up perfectly. Point M is not perfectly on point D. Point N is not perfectly on point E. So these shapes are not congruent because I cannot use translations, rotations, or reflections to line them up perfectly. Okay, go ahead and get that all written down. Number 3, it says Mauricio noticed that each side length of figure ABCD is equal to each side length in figure GHIJ. So it's saying that the length of the square meets the same length as this rhombus here. These are all the exact same size on here. So he says this proves that ABCD is congruent to GHIJ. This little symbol here means congruent. So we know that the two straight lines is an equal sign. Using the little squiggly means that it's congruent. Is his claim correct? Use the sketch tool or tracing paper. Well, these angle measurements here do not match up to this one, to the square. If I was to rotate this square, so that it matches up with H, so that A matches up with H, it would look more like, what is this, 5? It would look more like this. Oh, I went a little too far. Hold up, sorry guys. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3. It would look more like this. Nope, even that's not correct. Hold on, guys. This is definitely a lot more difficult with patty paper or the tracing paper that it's talking about. Um, so if I matched this side up, if I matched H and G up with AD, to make it a square though, it would match up like this. So ABCD would look more like the black one I did. The angle measurements do not match up here. So there's kind of two explanations on why his claim is not correct. Actually, there's really a couple different answers. So one, we can say the angle measurements are not the same, so it can't be congruent. We can also say, using the transformations that we did in the notes, we can say these are not congruent because we cannot map A, B, C, D onto G, H, I, J using translations, rotations, or reflections. So, whoops. This one here is the more technical one using what we're learning in class. But this one here is just automatically looking at it. If I'm just looking at it, I already know it's not congruent because my angle measurements aren't the same. If I was to look at the sample responses that Desmos gives the teacher, it says, knowing that the side lengths in one figure are equal to the side lengths in another is not enough to determine congruence. The angles should also be equal, and these angles are not equal. So that's like the first sentence I said. And then the second example it said is, I couldn't place figure ABCD perfectly on top of figure GHIJ using tracing paper transformations, which means these figures are not congruent. The fact that side lengths in one figure are equal to side lengths in another does not change that. So there is more than just the side lengths being the same measurement in order for shapes to be congruent. Okay, number 4. Students in another class were asked to convince their peers that the figures in pair C are congruent. Which of their arguments do you think is the most convincing? So, all of these are true statements about the two shapes, but we're looking for which one's actually a strong statement saying this is congruent because this is what's happening. So the first one says both figures have four sides and an area of 5.5 square units. Well, I could make another um, shape that has four sides and 1 point or and 5.5 square units because this shape right here that I just made off of the whim, it's four sides, and I know it's 1, 2, 3, 4, 5.5 square units. So while this statement is true about both these figures, that statement is not why they are congruent. That statement is true because they are congruent, but that's not why they are congruent. I can move the figures right on top of each other by translating figure JKLM down 3 units, left 4 units. So if I went from L down 1, 2, 3, and left 1, 2, 3, 4, and then reflected it over the side QP. So this is another thing that we really haven't done, but it's reflecting it across this line right here. Um, that would match up because that point L would be my point R there. Point K, if I went down 1, 2, 3, and over 1, 2, 3, 4, that matches up with this point on the line, which would keep it on the line. So you will not have problems this difficult using like this crooked line, but this response is what makes it congruent. Because they use translations and reflections, it is congruent. The last one real quickly, when I measure the side lengths of figures J, K, L, M, and P, Q, R, S, I get the same measurements. Well, we just found out that in slide 3 here, they could be the same side measurements and still not be congruent. So the strongest answer is this one because they proved that you can match them up using what we call rigid transformations or translations, reflections, and rotations. So, um, this explanation proves congruence by using rigid transformations. The sample responses that Desmos gives me says I can move the figures right on top of each other by translating. Oh, okay, so that's the correct answer. Then the actual explanation that it gives as an example is this argument is most convincing because knowing the side lengths and the area is not enough information to show that two figures are congruent. So you can also type this sentence in as well, which is very, very true. Just knowing the side lengths and the area is not enough information to prove congruent figures. Okay, slide 5 says describe a sequence of rigid transformations that will convince your classmates that the figures from pair D are congruent. So this one here is that easier with the stuff that we have learned in class. So I know that I'm gonna need to rotate it because it's currently facing the side. I need it to be facing up. So if I was to rotate this shape, I would want to rotate it this direction. That would be 90 degrees clockwise. 90 degrees clockwise would put my shape. I want straight lines. Hold on. Would make my shape look like this. That is what a 90 degrees clockwise rotation would be around the origin. And then I need to translate it over. And I need to count how many units over this would need to translate. So that is 1, 2, 3, 4, 5, 6, 7 units to the right. So the full sentence description of this sequence of transformations that proves that it is congruent is saying these two shapes are congruent because I can map the red figure onto the purple figure by rotating it 90 degrees clockwise and around the origin. I almost forgot that around the origin, which is important. I can type. And translating 7 units to the right. I cannot type today. Okay. So this is one of the things that we are going to continue to practice when I come back is um, describing sequence of transformations and proving congruency describing sequence of transformations. Okay, decide and defend. So Angel says that any two rectangles with the same area are congruent. Is Angel's claim correct? So drag the points to help you decide. I want you guys to do this one on your own. Do you agree with Angel that any two rectangles with the same area are automatically congruent? So you can move the points to make different rectangles. Remember, obviously these two aren't congruent. Automatically they don't have the same area. So if you were going to use this to help with this, obviously try to find rectangles with the same area and then determine if it is congruent or not. Okay, slide 7. Enough proof. Which statements are enough to prove that two figures are congruent? Select all that apply. So there is more than one correct answer. Again, I would like you guys to answer this one on your own so I can see how well you understood this. So the figures are both right triangles. Is that automatically going to make them congruent? You can trace one figure on tracing paper and move it perfectly on top of the other. Does that make it automatically congruent? The figures that have areas of 8 square units are both rectangles. Does that make it automatically congruent? You can move one figure right on top of the other by translating 8 units left. Would that make them automatically congruent? And the figures are both isosceles right triangles. Would that make them automatically congruent? So select all the ones that if you use that to prove congruency, it would actually prove it. Okay, slide 8. This says drag the points to create two figures that are not congruent, but someone might think they are. So this one's kind of testing your thinking skills. Try to create two shapes that are congruent. So the red one's already given for you. Can you move this purple one, like maybe even just moving it like that? Or move this purple one that would make people think it is congruent to the red one and explain how you know the two figures are not congruent. I want you to do that one on your own. Slide 9, how can you prove that these two figures are congruent? We already kind of did that one, so this should be kind of easy since we already did that. Slide 10, we're almost done, is figure ABCD congruent to EFGH. When you select yes or no, it is going to ask you to explain your thinking. So please use those strong sentences that we did in the notes and on this Desmos to explain yes or no. So complete this one on your own, and then, of course, as always, reflect on this lesson. Okay? If you guys have any questions, please let me know, and I will see you guys tomorrow. Bye, everyone.